Okay, section 4.5, we're learning about complex numbers, and the objectives here are to write complex numbers in standard form, perform arithmetic operations on complex numbers, use the conjugates, simplify square roots of negative numbers, and to find the solutions of a polynomial when they include when the solutions include more than just the real number set. Okay, so first of all, we're going to talk about the properties of complex numbers. First of all, the complex number system contains all real numbers. So numbers that we've dealt with so far, like -2 or square root 3, these are also in the complex number system. But they also contain numbers like this or this. Addition, subtraction, multiplication, and division of complex numbers obey the same rules for arithmetic that hold true in the real number system, with one exception, and that's that the exponent laws hold true for integer exponents, but not necessarily for the fractional ones. And you always want to make sure you write square roots of negative numbers that have I before doing any simplifications on those. So let's take a look at that. If you want more information on this, you can see page 297 in your textbook for some more information there. Okay. The complex number system contains a number I such that I squared is -1, and we're going to learn a little bit more about that in a minute. Every complex number can be written in the standard form of a plus bi, where a and b are real numbers. And then the fifth one is that a plus bi is equal to c plus di if and only if a and c are equal and b and d are equal. So we're going to look at some example problems with each one of those here now. First of all, let's talk about I. I to the first power is I, and I squared is -1. And then we could say that I cubed could be simplified as this I squared times I. Now, if I squared is -1, the -1 times I is going to give us -I for the I cubed. And then similarly, I to the fourth could be written as I squared times I squared, which would be -1 times -1, which is then equal to 1. And then the powers of I form like a cycle. For any power of I, it must be one of the four values I, -1, -I, or 1. And the way you do that, and you'll see an example in just a minute, is when you take the power and divide by 4, and you're looking at the remainder to determine what the value of I to some power would be. So here's an example of the standard form. We have to find x and y, and we know that -4x plus 5i is equal to 8 minus 6y plus I. So these are the real portions to the complex numbers. So we could take those two and set them equal to each other. So I could say that -4x is equal to 8. That's 8. And then I solve for that and you get x is -2. So that's x. And then similarly, to find what y is, then I would say that 5i is equal to -6y. And in that place, I can just go ahead and get rid of the i's, divide both sides by I, and I end up with this. And divide both sides by the -6. And I find out that y is equal to -5/6. And that's the solution to that problem. Okay, here we have a couple more examples. What we're going to do is perform these operations, and we're going to simplify. So let's take a look at these two first, a and b. And we're going to do a first. So first of all, in this example, all we need to do is combine like terms. So this can be rewritten as 2 minus 3i plus 1 plus I. And I'm just combining like terms. So the 2 and the 1, combine 2 plus 1 is going to give me 3. And then I combined these two terms, and that's going to give me -2i. And so that's simplified there. And now we're going to look at part B. And again, we're just combining like terms, so I'm going to rewrite it as 2 plus 3i. This negative needs to distribute, minus 4 plus 2i. Combining like terms, so the 2 minus the 4 is going to give me negative 2. Then I combine these two, and I get plus 5i. And that's it for those two. And let's move back and take a look at the next two problems. Okay, here we have a little more going on. We have multiplication, not just addition and subtraction. So it's going to take a little bit more work for these two. So in part C, the first thing we need to do is to distribute that 10i. This is going to distribute, and then that's going to give me 50i, and then plus, and then 10 times the 1/5 is going to give me 5. And then I know that I squared is, or actually this is going to give me I squared. So let's write that down. And then once I have that, then I squared, I'm going to simplify to -1. So I have 50i plus 5 times -1. And that gives me 50i minus 5. And that's it for C. Let's go back and make let's go back and rework this problem. This right here should actually be 2. So this should be 2, because 10 times 1/5 is 2, not 50. So we've got 2 times -1, so that should be minus 2. Okay, part D. In this case, what we need to do is we need to distribute the 3, and then we also need to distribute the I. So 3 times the 2 is going to give me 6, and 3 times the -5i is going to give me minus 15i. And then I have the I times the positive 2 is going to give me plus 2i, and the I times the -5i is going to give me -5i squared. Now here I'm going to simplify, combine like terms, and also change that I squared to -1. So combine these two, so that gives me 6 minus 13i, and then plus 5. And the way I got that plus 5 is I knew that this is -5 times -1, which gives me this. Now I have this, and I need to combine these two terms. And so that gives me 11 minus 13i. And this is simplified. Okay. All right, now we have two examples where we're going to find I to some power. And this is where I referred to looking at the remainder when you take a number and divide it by 4, because I occurs in cycles of 4. So in this case, we've got I to the 73rd power. So we take 73, divide it by 4, and that's going to give me and in this case, all we care about is this 1 here. This is insignificant. So that means that I to the 73rd power is equal to the same as I to the first power. And we know that's just I. Okay? And then we have I to the 54th power. So again, we're going to use division here for this. So we take 54 and divide it by 4. And we're left with 2 as a remainder. So that means that I to the 54th is the same as I squared. And we know that I squared is negative 1. Okay? So I to the 73rd simplifies to I to the 54th power simplifies to negative 1. Okay, now we're going to look at the square roots of negative numbers. If you have something like the square root of negative b, we're going to simplify that to I times the square root of b. And you're always going to write square roots of negative numbers in terms of I before you simplify them. So for example, here in this case, before I simplify this, then I'm going to write this as I square root 5 times I square root 10. And that's going to simplify to I squared times the square root of 50, which is negative 1. And then square root 50 is going to simplify to 5 times the square root of 2. So in this case, I get negative 5 square root 2. Okay, and then we have complex conjugates. The conjugate of a complex number here and here. So these two are conjugates because you notice the sign change. And then conjugate solutions is also something you need to know about. If a plus bi is a solution to a polynomial equation with real coefficients, then its conjugate is also a solution. Those two always come in pairs. And this is what occurs when you have a negative that occurs in the discriminant of the quadratic equation. Okay, so here we have a quotient, a complex quotient, and we're going to write this in standard form. So to write this in standard form, first of all, we need to get rid of the I that's in the denominator, and we're going to use the conjugate to do that. So let's think about what would the conjugate of this be. We've got negative 2 plus 5i over 1 minus 2i. The way we get rid of that 1 minus the I here in the denominator is we're going to multiply by the conjugate of this, which is 1 plus 2i. And then we multiply by 1 plus 2i in the numerator as well, because that's a fancy version of 1. And when we multiply this, we have to FOIL. Now, if you remember this, the reason we're multiplying by the conjugate is so that we can get rid of the I in the denominator. So what's going to happen is when you multiply the 1 times the 1, you get 1. And then the 1 times the 2i, and that's going to give you plus 2i. And then we take the 2i and distribute it, so that's going to give me minus 2i. You'll notice that what's happening to these is they cancel, and that was the whole purpose of multiplying by the conjugate. And then the negative 2i times a positive 2i is going to give me negative 4i squared. So if you can remember that when you multiply conjugates, then you don't need to use this piece here every time because it will cancel out. You can multiply the first term and the last term in this case. Now for our numerator, negative 2 times a 1 is negative 2. Negative 2 times the 2i is going to give me minus 4i. And then we have plus 5i. And then we have plus 10i squared. Okay, and I just need to go through and simplify this. Let's simplify the numerator first. And in my numerator, I'm going to end up with negative 2 plus I, or 1i. And then the 10i squared is going to simplify to negative 10 because I squared is negative 1. And then in my denominator, I'm just going to have the 1 minus the 4i squared, and I squared is negative 1, so that's going to give me a 5 in my denominator. And let's take this over and simplify it further because in my numerator, I can simplify the negative 2 minus 10 as negative 12 plus I over 5. And I can leave it as in this form, so this would be fine, or I can write it as negative 12 over 5 plus I over 5, or 1/5 I. And this is simplified. Okay, now we're going to write each of these as a complex number. So to write each of these as a complex number, and we're actually just going to do example B here. On this example B, I'm just going to take the 2, I can write this as 2 over 5 minus, now the negative square root of 11 is going to be I root 11 over 5. And that's simplified. In each case, you need to make sure you are simplifying and taking care. Anytime you have a negative, you need to change those to this first before you do any of the operations. And then we're going to find all the real solutions of these equations. So now we're dealing with polynomials, and this time with polynomials we have complex solutions. So that means we might have a solution that has a negative in the radical. So as always, you want to make sure you are graphing these to see what's happening. For example, on the A, you want to make sure you graph it and see if you have any x-intercepts. If you have x-intercepts, then on that one, you're probably not going to have any non-real solutions. So here's our equation here. And let's do zoom 6 and take a look at it. And this is the first one. This is A. Okay, so right now I am not seeing a graph. And if you think back to what we've learned, the reason I'm not seeing a graph is because my y-intercept occurs at 13, which is my constant. And I'm on a standard viewing window right now. So let's go and change our window. Make our y max something like 25. And I'll change this y scale to 5. And let's look at a graph now and see what happens. There we start seeing more. So you've got a quadratic, it opens up. You know you're seeing a complete graph here because both the end behavior, both it should be opening up, and both the on the left side it should be going up, and the same on the y. So now that we know that we don't have any real solutions because it doesn't intersect the x-axis. So from here, what we'd want to do is we go back here to this, and we are going to look for our solutions using the quadratic formula. So for this one, we're going to say x equals, and negative b is going to be 5 plus or minus. Square root b squared is going to be 25 minus 4 times a times c. And all of that is over 2 times a. And when we simplify, you'll notice why it is that you're going to end up with a negative value here. So this is going to give us 5 plus or minus square root of negative 131 over 6. And since we have this, that means we've got to take care of that negative, and we want to simplify this to 5 plus or minus I square root 131 over 6. So these are our complex, and this here should say complex solutions, because that is not a real solution. So 5 plus or minus I square root 131 over 6, which is, this is fine, or you can also write this as 5 over 6 plus or minus I square root 131 over 6. Okay, so we have that problem. Now let's take a look at the next one. And again, we're finding all the solutions, real and complex, here for this one. And again, you want to take a look at it on a graph to get started. Okay, so here we are. Got a graph. This is the same graph as the last one, and it's it's not going to work out for us. So it looks to me like we probably need to go further down. If you take this, the first thing you'd probably want to do is to take this equation and rewrite it as x cubed minus 64 equals 0. And this is what I put into my y2 is x cubed minus 64. So, you know, once you're looking at that, then you can see that your y-intercept occurs at negative 64. And that tells us that we need to see a different graph than what we're seeing right now. So I'll go over here to my window, and I'm going to change it so that my y minimum is negative 100. And I probably don't need to go up 25. Let's just change that to 10. And my y scale, since I'm going all the way to 100, let's change this to something like 20. And take a look at this graph. And there we get a better idea of what the graph of x cubed minus 64 looks like. So now we're going to go through and find our solutions. It looks like we have one real solution. And you could use your calculator to find out. To me, it looks like that occurs at about 4. So I'm going to try that out. Enter. 4. And it does. Okay, so that's your one real solution here. And that occurs at 4. So you know 4 is a solution. Now we have to find the others. So just like we've learned about with synthetic division, you want to go through 4 here, synthetic division. You've got 1. You don't have an x squared. You don't have an x. And negative 64 is your constant. And when I do this, I should get 1. So that's, I'm sorry, I should get 0 as my remainder. 4. And it works out. So I thought, so what that means now is that I have x to the second plus 4x plus 16. And I can set that equal to 0 and find those solutions. Now we already know that this is not going to produce any real solutions because we didn't see that it intersected the x-axis at any other point. So this is when you would want to use the quadratic equation again. And negative b is going to be negative 4 plus or minus square root. And b squared is going to be 16 minus 4 times a times c. And you notice you're going to get a negative here in the discriminant. Okay, and so then we would have x, we're going to simplify all of this. So you've got negative 4 plus or minus square root. And that's going to give me, let's see, I've got 16 minus, that's going to be 40 and 24. So okay, so then we simplify this further, and 48, we need to simplify the square root of 48, but so you notice you're going to have an I here. So negative 4 plus or minus 4i square root 3 over 2. And then we can take that and simplify it further to negative 2 plus or minus 2i square root 3. And so these solutions are in addition to the solution that I have here. So this is one solution, 2, 2, and 3 solutions here. So all of your solutions include 4, negative 2 plus 2i root 3, and then negative 2 minus 2i root 3. Okay, and that's all I have for section 4.5.